Hey everybody, I wanted to make a quick video to give you some pointers on graphing absolute value equations. And I'm just going to show you a few things, some helpful tips to get you making connections between equations and their graphs. So for example, like this is the quizzes that I assigned today. When you have an equation like this, it's, we need to keep referring and thinking about, first of all, the parent function, which is just the absolute value of x. And now we've added this a value in front, which is 4. So that's our a. That's the slope. That's one of the slopes, okay, is 4. Then we have this value plus 1, and that's the k value. That's going to be the y value for the vertex. The vertex is h comma k, and if you look at the vertex form of an absolute value equation, here's how it is written. Whoa, that was supposed to be a k. So the h and the k make the vertex. This is the difference between the x input value and the vertex value for x. So it's supposed to be a negative in here when h is positive. So there's no minus h in here with the absolute value expression. That means it's 0. That's the only thing it can be is a 0 inside there. So that tells you that the vertex is 0 for the x and 1 for the y. Okay? Now look down here. What's the vertex? This is now a positive, which means the x value is a negative, because when you do x minus -2, it becomes +2. And then the y value is a 5. So the vertex is at -2 and 5. It's like when we did point slope form. We had y minus y1 equals m times x minus x1. y1 and x1 was a point on the graph. And if they both showed negative, the x and y values were positive, okay? It's the same kind of thing here. You can see the vertex in vertex form. You can also see the slope. So this is how you graph it. Now, if I go into Desmos or the calculator, what I want you guys doing is you go to the graphing calculator, keep your parent function in there at all times. You're constantly looking at the connection and how it changes, and play around with it. If you put a 4 here, and that would be the slope is now +4 and -4, right? Because you have two sides. And then let's say I want the vertex at, pick a point. I want the vertex at -5 and -3. So that means I need a +5 in here, and I need a -3 down here, because this one was called for subtraction, so it's the opposite because it's -5. This one called for addition, it's opposite, so it says -3. So now I'm trying this out, and I'm going, okay, maybe I want it to point down now. So I'm going to put a negative in front of here, and look, it flips it upside down. You can zoom out. You can do some more. You could even start to make designs on here. Okay, what if I want to make an M? Challenge yourself. I want to make an M. If I want an M, I want this point to be the opposite. So it's going to be +5 here, but then still -3. Same slope. I want them to connect. And I want it to also point down. So I need a -4. And then I want it to be at +5. So I put -5. And then it's going to drop down 3. And now I can see that I've created this M. So this is what this lesson is all about. If you can make the connection between all the A, H, and K values and how that moves the graph and changes it from the parent value or parent function, then you'll understand how to graph it. To graph it, you always want to start with the vertex. So you would start with the point 5 and -3, put a point, then apply the slope. Down 4 over 1, down 4 over 1. And if you go down 4 over 1 this way, you're going to have down 4 to the left on the left side. And that's how you graph the absolute value function. I hope this video was helpful to you guys. And, you know, just keep, like I said, keep working on it, playing around with the graph, really explore and have some fun with it. It's actually pretty cool. Have a good weekend. See you guys on Tuesday or Wednesday. Bye.